All right. I think it's working almost. All right. There we go. Yes,
Awesome.
we're live.
All right, Cody, I can't remember if I wrote this description or if you wrote this, but either way, I think it's great. Uh, if you want to read that, you can, but I'll give my own kind of introduction to Cody Moss here. I've worked with him as a PHP developer. I think it was a lot of symphony work we did in the past, but he is a very, very talented developer, very sharp individual to work with. It was a pleasure working with him in past roles. He is the co-organizer of PHP Vegas. He currently has kind of switched hats over to more of the DevOps side of things and infrastructure, just kind of how his career has progressed. He's currently with Bethesda, working on some really cool things there. And, when you need someone that can figure out some really weird, complex issue, Cody's my go-to guy. So when I put up the bat signal, he's usually the one that busts through my window. So without further ado, let's kick it on over to Cody Moss.
Okay. Let's go ahead and nope, let's not click those buttons. Sorry, it's been a while since I've used Zoom. Damn it. I need to give it privacy access. Right back. Sorry, I forgot to do this one part.
We can edit the video, edit the YouTube.
That's fine.
I suppose we should have double checked that everything was fine. I forgot to do that.
No, it's my bad. I should have done a tech check.
Microsoft probably makes them use Teams, right?
Probably. I wouldn't be surprised. He did say he had to install Zoom, so.
Never to be seen again.
All right, Josh, now's your chance to tell us some cool jokes.
What did the elephant say to the framework?
I hope your name is Laravel.
How'd you know that one?
What's the actual punchline?
I don't know. I'm just making it up.
Okay.
Hey,
nice trunk.
Yeah, there you go. Sounds like SVN joke though.
Yeah. All right. Let me make you co-host again, Cody.
Yes, sorry about that. I forgot that when you first set up Zoom, you have to give it a bunch of permissions that it doesn't ask for right away.
No worries.
Okay, anyway. Yeah. Cool. So move the bar out the way. Okay, get this started. Okay, so this is a talk that I've been giving for quite a while, and it's called Kubernetes. It's automation, not automagic. I have been updating this throughout the years, so if there could still be some rough edges here and there, but just a heads up. Yeah. So Josh already gave me a pretty glowing introduction, but if you want to like get any of my details, here they are. I would recommend Discord or Twitter to really contact me. That email address, I check it maybe once or twice a month. So, but it's there if you want it. Okay. So we'll start off with what is Kubernetes, because it's kind of hard to jump in on how to deploy a PHP application if you aren't like fully up to date with what Kubernetes is. What Kubernetes is it's a clustering platform. It has self-healing, and it's basically an orchestration platform for your Docker containers. So whenever you're trying to deploy out your Docker images, you're just trying to get them onto boxes. You can do that with Docker Compose or just SSH onto the box and doing like Docker pull. But the problem is that doesn't scale, right? Because the thing is that's fine when you're a small startup and you have like one or two or maybe even like 5 boxes. But once you start getting to like the tens or hundreds, like that could take a long time to play out in an image. And also also with that, you're not going to have any self-healing. So like if your container just goes down, it's probably going to set off an alert somewhere, and you're going to have to get someone who's going to spin up that container. Well, Kubernetes comes with all of that baked in, because you have your liveliness checks, your readiness checks, and there's a bunch of goodies under the hood. We'll get more in depth as we go down through the talk.
You sound a little
Okay.
digitized. Are you running anything or on Wi-Fi or something?
I am on Wi-Fi, and I don't exactly have a
Maybe
wire.
it's your microphone or something. I don't know. It's not that bad. I could probably live with it, but
Okay.
Yes,
There.
Zoom
Now-
Zoom might be using a different mic.
Is it? Let's go ahead and take a look. See.
if you look at the thing that says mute, there's a little arrow right next to it that you can switch.
Yeah. It is using my headset already. Audio settings. Well, here's what we will try. Instead, I will just end my video because sometimes that helps. Okay, how's that?
It does sound a little bit better.
Yeah.
Okay. So yeah, we already covered this. Okay. So the building blocks of Kate's, that's just the short acronym way that people usually will say Kubernetes. And yeah. Okay. So the first part is the actual cluster itself, right? Because you can't really, run any workloads if you don't have any servers to run them on. Or some cloud providers also have their serverless, but it just means that they manage even the VMs for you. So you have to have a cluster that's made up of, like, you could be 2 or more nodes. You're probably going to want to actually set up so that you actually have like 3 masters for HA, and also then a few worker nodes. The worker nodes will be dependent on what it is you're trying to deploy, how many workloads you plan to run, the various things like that. But that's going to be on a case-by-case basis. So once you actually have where you have your worker nodes and your master nodes set up, or well, the primary nodes, because those are being renamed. Once you have the primary nodes up and the worker nodes, then you're going to be completely up and ready to spin up a cluster. Now, you don't necessarily need to have that many primary nodes, but it's because if you ever lose that primary node, the scheduler won't be able to schedule new workloads. It also won't be able to repair things because it won't have any idea of what the state should look like. But your workloads will continue to run on the worker nodes as long as they are still alive enough. You can also, for development purposes, and actually what we're going to be doing today with my demo is you can actually run a single node cluster on your own machine, or even on a server just for development purposes. It's both a primary and a worker node all combined into one. And there's actually also a really easy utility that will handle this called K3S, which is a Kubernetes distribution. It's built by the Rancher team, and it makes it so you can actually run Kubernetes on a very small, lightweight machine, but it's also a full certified version of Kubernetes. So you can actually do anything that you want that you can do on other Kubernetes clusters as well. Yep. And for some reason, my keyboard is refusing to work. So we will try that. Okay, pods. This is the smallest form of a Kubernetes workload. So a pod could be 1 or more containers, and it will also contain the volumes. It also handles all of the networking for the pod because it attaches itself to the CNI, which is a container network interface. So when you spin up Kubernetes, you're going to have to install a CNI, or if you're using a distribution, it will come with a CNI out of the box. And what a pod will do is it kind of makes like a work environment, attaches it to that network, gets an IP address so that it can network inside of the cluster. And then it will start spinning up your containerized applications inside of the pod. So you'll only have your application inside of a pod. This would be your PHP application. But in PHP's case, you also need a web server, right? Because if you can't host like Golang does on just a single port with a single binary, or a single type of service, because you can also just run this Nginx inside of it, you're going to need a web server. So that's usually where most PHP applications, when I usually help people get them up and running, and also when I run them myself, I have to spin up. I usually nowadays use Caddy, but I used to use Nginx, and then I also spin up PHP FPM inside of it, and I configure it so that they go to it. Now, when pods talk internally between containers, they talk on 127.0.0.1 because everything is a local host inside of the pod. But when you go to leave outside of the pod, that's where you're going to actually have to resolve DNS and get an IP address and actually attempt to leave. And that's actually how the service discovery also works. We will get more into that in a moment. But for right now, we will go ahead and jump over to my terminal. So here I have my, well, can everyone see my, yeah, it should. Yeah. Okay, so here I have my single node cluster, because if I actually go into nodes, you can see it's a control plane and a master node. Control plane on K3S means that that's where your workloads will run. Okay, so now if I go back to pods, I have a bunch of pods that have spun up because core DNS is needed. And some of these are just niceties that I've installed for later on in the demos. But we will go ahead and do a kubectl create pod real quick. And we're going to name it Nginx. And I'm going to give it the image equals Nginx latest. Did they change the API on it? Great. Yeah, it looks like they removed pods. Or no, it's just, yeah, pod JSON. So yeah. I'm trying to be clever and give a better example than what I have running here, but we'll go ahead and open this up. So this is a pod, and everything inside of Kubernetes is pretty much just YAML. You can also do JSON, but it will get transpiled into YAML. And then from there, it will then save all this data into the etcd cluster that's running inside of your Kubernetes distribution. So pods are ephemeral, which means when this one dies, all of its data goes with it. You can see that there is some volumes and stuff like that because it's going to want to save some information outside of it. But in the interim, it's just an ephemeral workload. But the problem is with that is when it's ephemeral, it can die and then it will never come back up. But then that's where you're going to get a deployment. So what deployments do is they spin up the pods for you based off of a template you give it. And it will find it because it will actually find the labels that you're going to put on the pod. You would then tell the deployment, hey, these are my selector labels. And then it will spin up however many replicas of that pod that you want. This is actually also how you can do your scaling with VPAs, HPAs. And one of those is a horizontal pod autoscaler. That's the one that's built into Kubernetes. VPA is done by the Kubernetes SIG, and it's up and coming, and that one's kind of neat. because it will actually monitor what your pod is actually using versus you just kind of setting your resource limits and requests on the pod. So the deployment will spin up pods based on the template. The template is where your requests for your resources are, your resource limits, what image needs to be done. It's the exact same. It's the exact same spec as a pod spec, except for it's just within the template structure. We will go through that in a momentarily when we get to the demo, because I actually have an entire Helm chart built out so that we can take a look at it. Okay. Now, services. This is how you're going to expose traffic to your workload, because when you make a deployment that spins up a pod inside of the cluster, it connects it to the CNI so it can talk inside of the cluster, but there's no way to get into that pod without like looking it up somehow. And that's where services come in. Again, it uses the same kind of deployment architecture where it will look up for a specific set of labels that are called selector labels. It will then find the pods that all have those labels and configure them to various different points. There's the types are node port, cluster IP, and load balancer. The way those work is a node port will open a port on using IP tables on every single node, on every single control plane node, and it will allow traffic to flow in from that port, and it will direct it to one of the many pods because it actually will load balance between all your pods as well. Now, when you do load balancer, this is usually going to be dependent on your distribution of Kubernetes or which cloud provider you're in, what kind of action that's going to take, or inaction. Because not every distribution that's a self-hosted version will support this. But anything like a cloud provider or K3S, they actually have it where it will actually spin up a load balancer. And it will start directing. For K3S, it'll actually spin up an internal load balancer that has a node port. So again, it's basically the same thing as a node port, except for it just magically routes the same. That's why it's pretty good to use for like demo purposes and also for development. But when you're actually like hosting production workloads, you're going to end up having a load balancer outside of your self-hosting to get to those node ports. Okay. But that also makes it so it's a little bit more cloud agnostic, because as you move the service from cloud to cloud, it could just spin up a load balancer and you just point your DNS at it and then it will get to the pods. Cluster IP is, it won't actually expose anything outside of your cluster, but it will actually give it where there is a internal cluster IP that other pods can look up via the core DNS or kube DNS service that's inside of the cluster. It'll actually use those DNS by default to do what's called service discovery. It will find the pods based on those selectors. Because when you spin up the service, an entry gets made in core DNS, and then you can use that to look up other services inside. And this is actually how, when you do ingress, you're going to have to set a cluster IP so that the ingress controller that runs inside of the cluster can actually get to the pods. And again, the service will still load balance between all your pods for you. And also, if you install a service mesh, some of them like Linkerd will actually use the same services, but it'll know how to like intelligently route it so that it will get you the optimum path even through the cluster. Okay. Now, here we go with ingress. So the way ingress works is it's just basically a reverse proxy that you install, and it uses some more Kubernetes objects to configure, to know what service it needs to look at for what host, on what path, and so on and so forth. But it will usually only listen on 80 and 443. Some of them actually have it so that you can configure it so that it will have the, so it'll actually configure it. So it'll also do TCP and UDP ingress for you. Though at that point, you probably should just use a node port, because configuring an ingress controller to do that is going to be a little hectic. But some people have some reasons to do it. Like one of them may be to actually try to make sure that you always have constant logging out of the same pods going in. Okay. Volumes. Okay, so when we were talking about pods, we already covered that they're ephemeral. And what happens is when they die, all the data goes with them because everything's in memory. And also there is some temporary storage that's put on the actual node itself. But when a pod dies, it will go and just clear that up for you. Now that's good, but that's also bad. Because if like your application is, like let's say MySQL, the important bit about MySQL is it's a database and we want to persist that data. So depending on the cloud provider, you're going to have already out of the box when you set up your Kubernetes cluster, usually they'll come with a storage class that will actually have storage already. So that when you tell it, hey, I need a volume that's 10 gigs, it'll spin up like in AWS for EKS, it'll spin up an EBS volume and it will spin it up for it to be 10 gigs. And depending on other annotations you put on that volume, it will configure it to be encrypted at rest with KMS keys and everything else that you want to do for security. So when you do spin up a volume, because you're going to have a storage class, and then you're going to have on top of it a persistent volume claim or a persistent volume, and then make the claim against the persistent volume. 9 times out of 10, you're only going to need the claim, and it will use the storage class and will automatically configure it. Sometimes you want a persistent volume that will persist for a bunch of pods instead of just one type of pod. Maybe you're running your MySQL backup inside of a container or inside of a pod, because you can do cron jobs inside of Kubernetes. There's also just regular jobs and stateful sets. Those are all types that cron jobs will run on a type, will run on a time. They run just a job pod, just like when you're running the job yourself. And then stateful sets are when you're trying to make individual persistent volume claims for separate pods so that they end up with individual data like Elasticsearch. You would do that so that each one of the nodes has their own persistent volume with their own persistent volume claim. But like in the MySQL stance, you would probably just do a deployment deployment of 1, or maybe you would do a stateful set of 2 so that way you would have a read replica. And then from there, you could have it so that you could spin up another job that would mount the persistent volume to take a backup or take a snapshot. That's just another way to solve it. Okay. Now we already kind of covered auto scaling with HPAs. This is where you're setting the limits. You're saying, hey, when it gets up to this memory or this amount of CPU, it's going to try to scale those pods out. It will try to distribute across all the nodes as much as possible. But sometimes Kubernetes has this idea of pressures. So you'll have network pressure, disk pressure, pod pressure. So basically, if it's noticing that there's a node that's kind of getting hammered, it will choose not to put the pod there. It'll put the pod somewhere else, if it can. Eventually, if it gets to a point where it's like, I've filled the cluster, I have no place to put this pod, it'll just stop trying to put it. And every time the scheduler spins up, it will continue to try to put it, but it will fail out usually. But that's only if you've absolutely filled everything and you filled your auto scaling group, and that's just a bad day. Certain charts will do this for you out of the box. Some will have it so that it's easily configurable. And this is also the one that's built into Kubernetes. VPAs are the alternative that you can install that I actually highly recommend, because it'll monitor your pod. And it'll actually even make recommendations to you saying, hey, I think you're wasting some resources. You could probably get away with, instead of making it 1.5 CPU, it will suggest that you make it maybe half of a CPU. Because when you're doing the resource limits and requests, memory is based off of whatever number you put in with megabyte, kilobyte, gigabyte next to it. CPU, though, it goes by milli-CPUs. So if you do like 100 M, that's 100th of a CPU core, versus like when you do like 500 M, that's half of a CPU core. And then when you just do one, that says 1 CPU core. And then the HPA will go based usually a lot off of that.
Is HPA an acronym?
Yeah, it's a horizontal pod autoscaler.
Cool, thank you.
And VPA is the same, but with vertical instead of horizontal. Okay, so sometimes usually you're going to want a very repeatable step to get your software into Kubernetes. And also maybe on top of it, you want to use other people's open source software inside of your Kubernetes cluster, because, you're going to want your workload and probably any other assisted workloads inside of the cluster, so that way everything can kind of jive with it. Like maybe StatsD, Grafana, things like that, to get stats off of your applications, or maybe even Prometheus. Well, there is an easy way to kind of share your workloads and even make your own workloads deployments much easier, and that's Helm. So Helm is pretty much the default package manager for most companies. They call their packages charts. They're going with the nautical theme of, like Kubernetes, everything is based off of being at the helm, charting your way, a bunch of ocean stuff. And so whenever you're deploying with Helm charts, it will actually make your life fairly simple, because it's just templated YAML. And that YAML is the exact same thing as all of the other Kubernetes specs, except for it could be conditional and other things. You can also make it so that it will dynamically change your image tag. Depending on if you're trying to deploy out a different version, you can have it so that your build pipeline says, hey, deploy this Helm chart with this override that sets the image tag to be something else. Or maybe you've made a Helm chart that is, or maybe you're working very generic pods that just need to have port 80 and a service, something to expose them. You can make it so that one Helm chart can deploy multiple multiple different types of deployments, because you can override any of the values that the developer sets within the templating. And we'll actually go through one in the demo. Okay. So secrets. I'm just going to kind of touch on this just a little bit, because you should probably actually end up using something like HashiCorp Vault, KMS, or Key Vault, something to get the secrets from an actual encrypted source. Because Kubernetes secrets, they are nice because they live inside of the cluster, and they actually have their own way of doing permissions and other things like that, to make sure that they're more protected than just your usual config map and your other Kubernetes objects. But they're only base64 encoded, so they are practically plain text. If you're too loose with your RBAC, everyone will have access to those secrets. And yeah, you should probably just use some other form unless you absolutely know that the secret isn't actually that much of a secret. Maybe it's just like a key for when you're sending up your metrics, you're giving like a specific key, or maybe it's a public key or something like that, right? Where it's a little bit of a secret, but it's not. Okay. Now we'll go ahead and go through the demo. Okay, so I am already within this repo. And here we're going to take a look at a couple things. One is going to be the Docker file, the Docker compose.yaml, because we're going to kind of compare the two. So when you're doing this, you can kind of get an idea. And I'm also going to need my browser. So we're going to just close that. And then we're going to open a new tab. Okay. So in here is my code editor. Here's the caddy config. It's pretty generic. I'm just saying, listen, on port 80, we want it gzip encoded. My root is in /app. Want to serve static files and then set up PHP and then some security stuff that came in by default when I use this. So by the way, this project is just Grav. It's a flat, or it's a file system CMS. You use it, a flat file CMS. It's built in PHP. It's actually a really cool project. I highly recommend it if you want to get into blogging, and because everything is just stored within here. But I also find it as a very good demo because it doesn't require a database or anything else like that. It's kind of all self-contained. Okay, so here's the Docker file. I'm setting up PHP with 8.1 because sadly 8.2 is not out yet, but come Thanksgiving, that'll change. I'm setting up the PHP INI to be the production one because they come baked in with a pretty decent production configuration. And then I copy my app in. And then because the way Grav works, it likes to be able to write in most of these directories. I got a little lazy and just did the chmod 777. Again, don't recommend this for production, but it works well for my demo. Okay, then I'm setting up the configuration because this is one Docker file to kind of rule them all. I'm building both the Kubernetes image off of this and the Docker Compose image off of this. Because in this case, we have FPM location app. FPM port is the default. And then, doing some get text and then copying my caddy file. So the way this caddy file looks, you'll notice here, this is the FPM location, FPM port. They will actually get, I set the env variables and then I do an env substring. This is just a really cool utility that will take environment variables and it will replace them if it finds them inside of this file. And then I print it out to the process thing. For caddy, I'm just pulling 2.6. I'm copying the code from the PHP container, and then I'm copying the config from the config container. So utilizing layers. Here's my Docker Compose. It just builds it. So I could do where I'm doing nerd CTL. Just think of it as Docker. Because it's pretty much a drop-in replacement for Docker, except for it comes out by default with Rancher Desktop, which is the tool I'm using instead of Docker Desktop. So you just do, for most others, it would be Docker Compose. But in this case, I'm going to be nerd CTL Compose. And I've already built the images because I didn't want to just sit here and have you guys wait like 5 minutes while I figured it all out. So we're just going to go ahead and do up. And we'll go ahead and just leave it so it takes over my terminal so you can see it's working. In this case, I see that I have FPM. And I can see that, yeah, caddy is up too. Cool. So now if I come here and go to local host 8080, I get this lovely grab page. Cool. So we have a containerized workload and we're using Docker Compose. Now, how do we get this inside of Kubernetes? Well, there's going to have to be a couple changes that need to be made. One of them is, unless you're going to like here, the FPM location, because like I said earlier, when I run PHP, I usually run Caddy and PHP inside of the same pod. They're two different containers. So this FPM location, I need it to actually change to 127.0.0.1. So when I go here to this build, you're going to notice that I'm overriding this build argument. It's actually the only build argument that I'm overriding, and then I'm also giving it a name and the sample app web server, because I need two images, one for Caddy, one for PHP. And then I override it so that it knows that the FPM location is in 127.0.0.1. I copy and pasted this. Technically, the PHP one doesn't need it, but oh well. Also, there would normally be a push step here because Kubernetes usually will pull from a container registry, mostly because your Kubernetes clusters are going to be remote from you. So you're going to need to push up your image to a container registry so that way it can access it. Now, that could also be a private registry because Kubernetes does actually have it. So when you're setting up the pod, you can do what's called an image pull secret. And that will actually take the secret from Kubernetes from within that namespace, and it will authenticate when it goes to pull that image. And then, so in this case, I'm kind of cheating because my Kubernetes cluster is here on my local within this namespace. If I was using the Docker API, this actually wouldn't be needed because it's smart enough to know that if I have the image on my local, it's also available to my Kubernetes cluster. nerdctl is the only one that's special with the whole namespacing. Okay, that's the one difference between the two. So yeah, I'm just building and then pretend pushing it somewhere. And I'll go ahead and just run that. It should just pull entirely from cache. Yeah, it's all coming from cache. And then, yeah, so it pulled those images, it built it all out, configured Caddy so that this one will actually have my new FPM port. Okay. And now I have this Helm chart. So in here we have templates, we have a deployment, and how I created this is I just said Helm create, and then like here I'll type demo, and here you'll notice that this new demo popped up and it filled it out pretty much the same. But I did make some changes because one of the changes is usually this will come with only one container. So here's my deployment. This name is for the deployment. These labels are for the deployment, but this is not what the deployment controller will look at to find the pods. Those come later. Here's where you can set the number of replicas. You'll notice that everything is like this .values, .replicas. That's all coming from here, this values.yaml. In this case, replica count is 1. We could scale that up to 2 or 3. Doesn't really matter. Assuming that you have the resources for it. Now, I had to change a couple things around because, so here's my selector, and this is going to say, hey, this is what labels I want you to match on. Helm will come out of the box figuring that out for you. You can change the logic of this within the helpers.tpl. That's because this is where this include is just doing a template include, and then they put all the logics within the helper here. So in this case, we'll see selector labels. It's looking for a name and instance where it's going to match these two values. So it's just going to keep filling them in. Okay, so that's going to say how to find the pod. And then here in the template, we're going to have our metadata annotations. This is some metadata that other controllers and operators can use to modify this pod. Like when you're doing Linkerd with the services, it's going to you would inject the linkerd annotation, so that way it knows linkerd when it sees that, it'll go, oh, hey, here, inject my sidecar, so that way it joins the service mesh. Okay, and then here's these labels. You'll notice that the selector labels are the same, so they're both going to be generated. This is actually going to be the labels put against the pod. This is going to tell the deployment how to find this pod. Okay, if we had a secret to pull the image, this is where it would be put, but in this case, we don't need it. Service account, everything. When you spin up a Kubernetes pod, everything gets a service account, but if you don't specify one, it's just going to use a service account that's called default that exists in every namespace. If you're doing any RBAC, make sure you don't really modify that service account, make your own service account, and then bind roles to that service account, because basically if I were to comment this out, this would still get that default service account. So it's just better for control if you're generating your own. Security context, this is how you could set if you want your pod to run as root, not root, if you want to give it special admin mods, like let it control the network and stuff like that for the hosts. You can do that here, because some people will actually run VPN pods inside of Kubernetes that will, they'll put HA proxy in, and then they'll give it like a sidecar VPN so that they can direct through that HA proxy to maybe another site or to another to another site, to another availability zone. The options of networking are endless. Okay, now here's the workload itself that we probably care more about, is the containers. So in this case, I have one that's going to be named chart name - web server. This is going to be caddy. And how I know that is because here in values, I set this one to sample app and this one to sample app web server, which we just saw built here. And I set it to the tag of coup. And then we also set the pull policy to if not present. So this could also be a pull policy of always, never, and yeah, those are the only other options. Never, it'll never pull, so it's got to come from cache. Always, it will ignore cache and will always go. If not present says if it's available in the cache, I'm just going to use it, but if it's not, then I'll pull in a fresh one. Okay. So back to here. Yeah, we'll go ahead and collapse this bit so we have more room. This is where I'm setting that image. You can see web server.image.repository. It's .annotated. So when you go through the values, it's php.image.repository. Okay. Yeah, that's all I changed. Image pull policy gets set there. Okay, so here's the other bits. So ports, I'm going to set one that's for HTTP, which is just port 80. And it's protocol TCP. This is going to expose a port inside of the cluster on port 80 of this pod. And I also gave it a name so that way I can easily reference it. So in this case, we have HTTP. So in my liveliness probe and my readiness probe, I'm just checking for / on port HTTP. Now you can actually have it so that your PHP application would do /healths or something like that, so that you're not actually connecting to the database and doing a bunch of other stuff for just to check to see if the PHP pod is alive. Or, well, in this case, the caddy pod. So I know it's going to, this is going to check out, and so is this, because they're both doing the exact same thing. Here's where I can set resources. In this case, my resources are blank. So that's just going to say that it can use as much as it wants, and it will grow from there. In this case, it shows limits and requests would be how you would do this under this resources. And this would be 100 milli CPUs and 128 megabytes. Yeah. So for the PHP pod, it's all the same except for this FPM. We're going to open port 9000 so that way this pod or this container can talk to this container. And then I also set up a TCP socket check just for the port FPM because I just want it to connect. And if it can make a TCP connection to this port, it'll go, okay, cool. And it'll just die off and then say that the pod's ready and alive. These node selectors, affinities, and tolerations is how you're going to select which kind of nodes it's going to go to. Node selector is it's going to look for a label that's put on the node and go straight to that node. Affinity is how you're going to set which kind of node a pod's going to favor, but it's not necessarily going to always do that if it can't quite fit the affinity and fit the pressure. Tolerations, that's where you can put taints on nodes, and then you could say that this pod can tolerate that taint. Because when a node is tainted, no workload's going to go to it unless it can tolerate. In this case, like your CNI and basically a lot of the system pods, they're all going to tolerate everything because they need to exist on every node, regardless if it's actually in action or not. But the taints are a good way to drain a node and make sure no new pods get put to it, because you're going to taint it, drain it, and then from there, that you can operate maintenance on that node without really messing with anyone's workloads. Okay. So there's that. Service. In this case, I'm looking for the target port, and then I'm going to expose a port. In this case, I think I made it port 8080. Should be. Actually, I made it 8090, and I made it a load balancer. So in this case, we're going to see that this type is going to be load balancer. It's going to be on port 8090, so that way my 8080 wouldn't conflict. And then it's going to look for selector labels. Again, it's using the exact same function. So these selector labels are going to definitely exist on the pod. We also have an ingress. This is very highly configurable, and also depends on the version of Kubernetes because they changed the API quite drastically. I'll kind of show this one working, but if you want to dive more into it, you can just run a Helm create and then start breaking through like the ifs and also the variables that are getting set and so on and so forth. But we'll actually look at it rendered. It's a little easier to read that way. Okay. Now I'm going to go ahead and bring this back up. So we're going to run a Helm install. I'm going to call this grab. And then I'm going to point it at a directory. Now, this doesn't have to be a directory. It could also be just a name of one that exists in a Helm repository, because Helm has its own repositories. And people can host the Helm repositories, and you can add them, and you can pull in community Helm charts. But in this case, this one exists locally, so I know it's in Helm. I know I named it grab. Okay. There, it told me it installed. I could see grab spun up instantly because it didn't have to pull the images because I already built them. And also you can see that it spun up a load balancer here that if I were to go take, it's probably gonna be, yeah, you can see that its source port's 8090. Okay. Just to kind of show that that's working. This is grab from Kubernetes. I know it's very, very unexciting because it's the same, but if I go back to 8080, because I stopped it, you'll notice it stopped running. So this is definitely coming from within my Kubernetes cluster. Okay. Now let's get a little bit more fancier. In this case, I've already installed it. I'm going to do an upgrade. I'm going to do a -f because I prepared another values file. So Helm grav values dash ingress. That's what I called it. So if we take a quick gander at that, it's just me setting the service to be a cluster IP, port 80, and then I'm enabling the ingress. If I come over here, the ingress is enabled to false, and then I have rancher.local and slash is a implementation specific. This means that it's just going to always forward just everything, and it's not going to really care about it because it's like, okay, if anything starts with slash, just send it. Is how that works. And so in this case, you'll notice that I actually have this traffic pod, and it also comes with its own load balancer. And this traffic pod is my ingress controller. This comes with K3S out of the box, which is pretty handy. So I didn't need to install this at all. It just came with Rancher Desktop. If you run any version of K3S and make no modifications to its settings, you're always going to get this ingress controller. So you can disable it if you want. Okay. So I'm going to go ahead and do an upgrade. You'll notice that the other service load balancer that was here, my computer is trying to reboot. I apologize. But the other service load balancer that was here is now gone. Grav is still here. But so in that case, if I go back to here and try to do 8090 again, it's never going to load because it's like, can't find it. In this case, I already made a change to my hosts or my /etc/hosts, and this will be rancher. Oh, it still got stuck on there. Okay, rancher.local/. And there we have grav again. And this time it's going through. If I check out the logs here and refresh, I guess I haven't set the error only. But yeah, so if I go to ingress, you'll notice it says it's in the default namespace, the name is grav. It's looking for the hosts of rancher.local on port 80. And if I open this, that coincides with that. So it's going to look for path specific implementation for rancher local. And the name, so you'll notice it says backend service name grav on port 80. And so what this service is referring to is if I go to service, you're going to notice I have a service named grav right here that's a cluster IP, and it actually has port 80 open. So it's going to listen on port 80 and it's going to send it to HTTP. And that HTTP is, so right here, ports, name is HTTP, port 80, protocol is HTTP, or I mean TCP, not HTTP. And then the target port, this is going to refer to that name that exists on the pod. So I go to the pod, do a quick YAML. Here we'll see that ports, container port 80, name HTTP, protocol is TCP. Oh, and also you can see our lovely logs here. As I refresh, more pop. Okay, so I just threw like a million things at everyone. Is there any questions?
You can use the Q&A chat too for anyone who's participating as an attendee. Logan, maybe check the YouTube too.
Yep. Yeah, for sure. I'll check the YouTube here. I have a couple questions queued up for you, Cody. Great presentation. So can you, this is you kind of went over a lot of different concepts of like how Kubernetes works. Can you briefly mention and maybe talk a little bit about what a service mesh is, since I think almost all production clusters are using them at this point?
Okay. So a service mesh is, okay, so I'm going to go based off Linkerd here because that's the one I'm most familiar with. They all kind of have like their own little nuance. So what a service mesh is a way to discover other services and they mesh them together so that they all can talk. And what I mean by that is it will mesh through the network so that it will find that service. And if like one node goes down, it'll like do what your ISP does. It will find a new route to another pod. So that way they can find each other. And also another great example of this is it will also encrypt that it'll encrypt that communication because every service mesh I know of also does mutual TLS. So that means there's TLS on both the client and server side, and it will basically form a pipe to send data back and forth. And that's a very high overview of a service mesh.
Great. Yeah. And I know there's like Istio and Console and a few other ones, and it can get pretty complicated. Just figured it would be helpful here to just kind of mention if people are in their production cluster and they're like, what is this other container doing next to my application container? Cool. So the other thing, I couldn't remember the templating stuff in Helm. Is that with the Python templating? If people kind of had some questions on how Helm charts the templating works and they wanted to look up, do you remember the Python, the name of the templating engine for
You
Helm
think about, like,
charts?
Cookie cutter?
It's actually Helm is written in Golang and they just use Go templating.
Oh, okay. So it's not the Python templating. Okay.
Yeah, no, it's just Go templating. If you go here in their docs, they actually have a how-to that will go through a couple things, and also the introduction. Like this will actually like take you through that Helm create command, and also through installing it and kind of running it. Basically, if you just read this from top down, it will give you a lot. Like actually, probably about here. The rest of it is reference. So at chart template guide, so basically from the introduction to chart template guide, if you just read through that, like none of these pages are like full, like they're not like super huge lengths of documentation. You can probably get through that amount of reading. Like if you're a slow reader like I am, it took me about 45 minutes to get through all that. But then like, you know, I had to play with it a little bit, toy with it, and then reread it a couple times because until you do it, do you really learn it?
Awesome. Yeah, that is the best way for me to learn, and I think a lot of people as well. Any other questions for Cody? So typically at the end of these things, we will bring everybody up on stage. We'll stop the recording and then bring everybody up on stage. So you know, if you want to save your question for on video on Zoom, but not on the recording, feel free to do so. Thank you so much for giving the talk this month, Cody.
Yeah, Just one last thing, because I realized I just only typed it in the Q&A and I didn't actually say it, so I don't know if YouTube can see it or if others could actually see it. But all this code is available up on my GitHub in /presentations. Here in this demo, CMS demo, is that Grav app that I was messing with, and you can see I just pretty much just cloned exactly what theirs was, and then that's where the Helm chart is, my caddy file, the Docker file, and the Docker compose. So that's all available up on GitHub.
Awesome. It definitely helps to look at code. Everybody watching tonight, everybody, the panelists and attendees, make sure to click on Cody's GitHub link there and throw him a star. Give him a like. Help a brother out there. So I know those stars definitely help with exposure and everything. So the least we can do is help Cody out there with a star. Well, I don't see any other. Oh, maybe we have one more.
It just says thank you, great presentation.
Yep.
Thank you, David. You're a great audience member. As well as everyone else. Thank you all for having me.
All
Thank
right.
you, Cody.
So stick around. I'm gonna end the recording now. Thank you for joining us. And again, please join us next month for Ian's talk on PHP 8.2. I hope you guys have a good Thanksgiving and enjoy the rest of your November. I can't believe the year's almost over. All right. Bye for now. Bye.
Bye-bye.